Okay, chemists, today we're going to go over the 2016 AP Chem Practice Multiple Choice Exam. Number 1 states, in which of the following liquids do the intermolecular forces include dipole-dipole? Those are polar. So if you remember, when it comes to polarity with tetrahedral molecules, there has to be the same atom on all 4 bonds. Otherwise, it can't be symmetrical. So A, fluorine, that's completely nonpolar because each fluorine has a electronegativity of 4.0, so it's completely nonpolar. B and C are symmetrical because they each have the same atom. D is the one that is tetrahedral but not symmetrical. 2, which of the following best helps explain why an increase in temperature increases the rate of a chemical reaction? So this has to do with collision theory, which states that in order for atoms to react or molecules to react, they have to have enough energy, called the activation energy, and the proper orientation to have what we call effective collisions. So at higher temperatures, the molecules are moving faster. Temperature measures the speed of the molecules. So more molecules are going to have the right energy, which is called the activation energy. 3, a sample of a hard solid binary compound at room temperature did not conduct electricity as a solid, but became highly conductive when dissolved in water. Which of the following types of interactions most likely found between the particles? Well, if they're telling you it does not conduct electricity as a solid, it cannot be a metal. So metals don't really dissolve in water, but they do conduct electricity as a solid. Ionic compounds conduct electricity as a liquid or when dissolved in water and aqueous, but not as a solid. There will be a question on the AP exam that asks you to show that you know that special difference. 4, we're talking about the production of NH3, which we know is an equilibrium problem. So that's what those back and forth arrows mean. The delta H is less than 0, means that it is an exothermic reaction. So ammonia was synthesized in the presence of powdered catalyst, leading to the equilibrium. Which of the following changes would result in more NH3? So you're looking for something that's going to push the equilibrium to the products. So the things that you can count on to push the equilibrium would be, you can add a reactant, add a product, take a reactant away, take away a product. You can increase or decrease the temperature, and you can also pressurize it. And you can do that by either increasing the pressure or decreasing the volume. So in order to shift to the products, you're going to be looking for something that is either adding a reactant, removing a product, removing heat because it's exothermic. So the correct answer is D. Okay, polarity. So you would have to know that fluorine has 7 valence electrons and wants to share one more in order to get to 8. Oxygen has 6 valence electrons and would have to share 2 more in order to get to 8. Nitrogen has 5 valence electrons and wants to share 3 more to get to 8. I left off the lone pairs of electrons on there. Fluorine has 3 lone pairs of electrons. Oxygen each has 2, and nitrogen each has 1. So you've got a single bond, a double bond, and a triple bond. So single bonds are the longest with the least amount of energy. Triple bonds are the shortest with the most energy. So the correct answer is A. Number 6 is Coulomb's law. So when we're talking about weakest interaction, I wrote the formula down there. Just remember, when you see the word Coulomb, you want to think charge. And how they interact with each other is going to be mostly related to the charge. The force or lattice energy, or the force of interactions, depending on what you're talking about, is going to be directly related to charge. The larger the charge, the larger the force. It is inversely related to radius because the radius is on the bottom. So the larger the radius, the less the force. So we can automatically cancel off, cross off calcium and indium because they have those bigger charges. So now we're between lithium and sodium. The correct answer is going to be sodium because sodium is larger. Number 7, increasing polarity. So you're just going to subtract the electronegativity differences between the different atoms. And remember, you don't have to know these electronegativity differences. They will give you them if they're asking you a question on them. So you're going to subtract the two atoms involved, and the correct answer is A. Number 8, this is successive ionization energies. So you notice the first one comes off with less energy than the second. Second one's about twice as much energy. That's what you expect to see. But the third one jumps up. When you're taking off that third electron, the ionization energy shoots way up. And the reason for that is because the first two are valence electrons, and the next one is a core electron from not the valence shell, but the shell inside of that. So the correct answer is C. Here is a weak acid, strong base titration. Here's how I know this. The initial pH is between 3 and 4. Not impossible for a strong acid, but it would mean it was super dilute. The dead giveaway, though, is the pH at the equivalence point is about 9. So that means it cannot be a strong acid that's being titrated, because the pH of a strong acid, strong base titration is at the equivalence point is always going to be 7. So that's how it tells me that I cannot be dealing with a strong acid and a strong base. So I can cross off A and B. So look at that. Once you figure that out, you can say it's a weak acid titrated with a strong base because the pH point is at the equivalence point is greater than 7. You don't even have to entertain D whatsoever because the pH at the equivalence point is not 7. Here's a particle picture. You'll see that in the top picture, you can almost count how many atoms are on the outside, how many ions are on the outside being exposed to the other reactant. You can see that there's lots of atoms or ions in the center that are not being exposed to the other reactant. In the second picture, you can see that there's just a few atoms that are on the inside and not on the outside exposed to the other reactant. So the smaller particles actually have larger surface area. You can tell yourself that and convince yourself that of counting the atoms on the outside in the two different pictures and comparing them. So the smaller the particle size, the larger the surface area, the greater the reaction rate. Large particles have small surface area and lower reaction rate. So the correct answer is C. 11 is a combustion analysis problem. You got 12 grams of carbon, 3 grams of hydrogen, and 8 grams of oxygen. We know we cannot compare grams to grams. So the first thing we have to do is change it to moles. So when you get moles, when you change it to moles, you'll see that you have 1 mole of carbon, 3 moles of hydrogen, only half a mole of oxygen. You can't have half of an atom, so you have to multiply by a whole number to get a whole number. And that's where you get 2 carbons, 6 hydrogens, and 1 oxygen. Number 12 is a KSP, so you're looking for the highest concentration of Cl2. Well, you look at the last two, silver chloride and mercury 1 chloride, they're both have very low solubilities. I calculated the value for X, but you can reasonably cross those off. Now we can go to the ones up on top, and not only is lead chloride, lead 2 chloride, the most soluble, but we also get 2 ions of chlorine for every 1 formula unit of lead 2 chloride. So that's automatically going to be the correct answer. Let's look at these Maxwell-Boltzmann distribution of atoms. Remember that speed is on the x-axis and fraction of particles. So read what we got going on here. The area underneath all of these curves should be exactly the same. But the larger the particles, the slower they move. So more fraction of molecules is going to be moving at a slower speed. So this can be confusing because it looks like the correct answer has a higher curve, and you would think that for the higher temperature or the higher speed, and that's not the case. Remember, kinetic energy equals 1/2 mv squared. So the larger the molecule size, the smaller the velocity will be, the slower it will be moving. So B does not make sense. None of these other ones make sense. You just kind of got to get that vision in your head of what a Maxwell-Boltzmann distribution looks like if you don't understand. Okay, cell potentials for decomposition reactions. Okay, number 14 asks you to find the standard reduction potential for the reaction above. So basically what you're doing is you're looking at this target reaction up here. You're seeing that you need 2 of H2O2 in the reactant side. That means you're going to take the second equation and flip it. And when you add those together, you're not going to multiply. What your key is, you're going to have to make sure you have the same amount of electrons that are lost as they are gained. So you have to multiply it by 2. And when you add them together, you get 0.68. Which of the following is true for the decomposition? Well, it happens spontaneously. So we know that delta G is less than 0, and we know the products are favored, so K is going to be greater than 1. So the correct answer is C. 16. Which of the following will most likely increase the rate of reaction represented above? So in the reaction above, things that have increased the rate of reaction would be increasing the temperature, increasing the concentration, or in this case, decreasing the pressure. So you're going to look through there, and the only one that fits. Also, catalysts adding a catalyst lowers the activation energy and speeds up a reaction. Which of the following molecules is least soluble in water? You're going to look for the one that's least polar. So the correct answer is going to be B. It is nonpolar because it is symmetrical. At room temperature, iodine is a molecular solid. Which of the following provides a characteristic of iodine with a correct explanation? It has a high melting point because of its weak intermolecular forces. That would not be the case. It would not have a high melting point. It would have a low melting point. So that sentence does not make sense. It is hard because it forms 3-dimensional covalent network. That's a network solid. You're going to look for carbon, diamond, graphite, silicon dioxide, stuff like that. That's not a covalent network solid. So you got to kind of just remember those covalent network solids and have that red flag go off. That those are the ones we're going to be talking about. It's very soluble in water because its molecules are polar. It's not polar. It's nonpolar. So C is the only one makes sense. Based on the information above, which liquid has a higher equilibrium vapor pressure? Well, what vapor pressure comes from is when you have weaker intermolecular forces, more particles can escape into the gas phase. So you're looking for something to say that obviously CS2 is going to have a higher vapor pressure because it has a lower boiling point. So you're looking for something that tells you that CS2 has weaker forces, and the correct answer is B. Based on the information above, which of the following has the strongest acid? So because KEQ is greater than 1, that means that the products are favored. So that means that the acid that dissociates the most is going to be the strongest acid. So if it favors the product side, that means that the least amount of HX stays together. Y is a base. So in that case, you would not call it the strongest acid because it's acting as a base. Okay, this is a analysis of error. So if you looked at some of the lab questions or the lab techniques document that I posted there, you would find some of these things here. 3 trials. According to the instructor, the mass of precipitate recovered was 5% higher. That means something that must be in there. So if the pores of the paper were too large, some of the solid would go through and the mass would be lower. Not all the precipitate was transferred to the filter paper. That's also going to be lower. The NaCl solution was too concentrated. Well, we already had excess. So we had plenty of NaCl. That's not going to affect that whatsoever. So what happens if you don't rinse the precipitate, some of the spectator ions can become trapped in between the particles of the precipitate. So you would rinse them out. So the correct answer is D. Okay, so we've got a strong acid, strong base titration here. Notice the pH at the equivalence point is 7. It says at the point labeled R on the curve, which of the following ions are present? That's the equivalence point. So that means that there is no H plus or OH minus present. So the correct answer is A. One student titrated with 1 molar instead of 0.1 molar. Well, all that's going to happen is the equivalence point is going to be reached earlier because each drop or each quantity you put in there is going to have more moles. So it's not going to change the equivalence point. It'll still be at 7. It's just that it's going to get there much quicker. So this is a 1-to-1 relationship. So these are going to match 1-to-1. So if you have 0.1 molar HCl and 0.1 molar NaOH, that's a stoichiometric ratio. If you use 50 milliliters of each, you're going to get exact stoichiometric ratio. Number 2, all that's going to happen is you're going to have an excess of HCl. So still only 50 milliliters of HCl will react and the rest will be left over. Therefore, the correct answer is B. So this is an MCAT. You just have to recognize that when you add them together, your final volume is going to be 20 milliliters, which is also 20 grams. So when you do MCAT, you're going to use the 20 grams, and it's going to be kilojoules per mole. So I have 1 molar, but I don't have 1 liter. So I have 0.01 liters. That's why I divided it by 0.01 moles. So have the units tell you what you're supposed to do in that. Look at the units of the answer, and that'll keep you from just saying 504 kilojoules. So I'm going to answer one of those last two. So this is elementary steps. Remember, the rate law cannot be determined experimentally because the coefficients assume that this reaction happens in one step. So it's not that it will always be different than the actual reaction, but you have to determine it experimentally because a lot of reactions happen in elementary steps, and therefore you can't make that leap. So if you're asked a question about elementary steps, go to the rate law. The elementary step that is the rate determining step is going to have 1 NO2 and 1 F2 because their superscript is 1. So the correct answer is B. This is VSEPR. 27 is about a VSEPR. It is valence shell electron pair repulsion. Remember, lone pairs of electrons warp the bonds. So the more lone pairs of electrons you have, the more the bond is warped. So the first one has 4 things going on around the central atom. No lone pairs, 109.5. Second one has 4 things going on 4 things going on around the central atom. I don't know why I wrote 105. That should be 107. 3 bonding pairs, 1 lone pair. So it's going to warp the bonds down a little bit. C has 3 things going on, no lone pairs, so it'll be 120. D has 3 lone pairs, so it'll be a little bit less than 120. So the correct answer is B. So in this one, what happens is you have longer chain carbons, and they end up with like one side, like these molecules will end up with one side that's polar and one side that's nonpolar. The longer the chain on the nonpolar side, the more it's going to have London dispersion forces. So the correct answer is B. Okay, this is a Beer's Law question. It says, how long did it take for 75% of the initial amount to react? So if 75% reacted, that means 25% is non-reacted. So 25% will still remain as the reactant. So 25% of 0.62 is going to be 0.155. So that's going to be closest to 300 seconds. Lower concentration, if you diluted it, it's going to have a lower concentration. Therefore, the reaction rate is going to be lower. Okay, here we are looking for the C25H30N3+. That's what we want to find. So you would read when it's just that. The other stuff is going to be interfering with it. So we're going to look for the maximum range, and that's just reading the graph there at 590. Number 32 is an equilibrium problem, and it's got a K value of 1.5 times 10 to the third. That's a very high K value. Anything over 1 favors the products, but a number this big basically means it goes to completion. So you're going to look for anything that shows that you're going to have more products than you do reactants, and that correct answer would be C. This is another KSP problem. So one of them is going to precipitate and one of them is not. So you're going to look and see if it's greater than or less than. If the KSP is greater than, then more will dissolve. So you're just going to compare the K value to the KSP value. You're going to compare the X value to the concentration and tell whether it's going to create a precipitate or not. 0.1 molar. So remember, you can skip straight to Ka equals X squared over IC. Initial concentration. The initial concentration is 0.01. So I'm going to have 4 times 10 to the minus 4. I'm going to multiply it by the Kc. I'm going to take the square root of it, and then I'm going to take the pH of it. So the correct answer when you take the square root is going to be between 2 and 3. Remember, you can look at the power and tell me what the pH is. 2 isoelectronic species. They both have 18 electrons, but calcium still has 20 protons, whereas argon only has 18 protons. So the increased nuclear charge, what's going to hang on to the electrons is always the pull of the protons in the nucleus. So you're going to look for something that is talking about the pull of the protons in the nucleus, which has increased effective nuclear charge. So those 2 more protons in the nucleus are going to hold the electrons with more energy. So 36 is a van der Waals real gases. So that's a van der Waals equation. Real gases and ideal gases can be differentiated by the current situation or the current variables around. So what that means is gases act most like ideal gases when they're under very low pressures and very high temperatures. So think of the opposite is what would you do to a gas to turn it into a liquid? If you wanted to turn a gas to a liquid, you would increase the pressure or decrease the volume. When you increase the pressure, the particles get closer together. What that means is the greater the size of the molecule, the more it will behave like a real gas because of the actual volume of the particles and the attraction between the particles. So it has to do with polarity and it has to do with the size of the particles. So when you're talking about whether gases, which gases will behave most ideally, you're going to look for small nonpolar gases. When you're looking for gases that are going to behave more real, less ideal, you're going to look for larger gases with larger molar mass and polar molecules. Argon is a bigger molecule, so it actually, the gas particles have volume themselves. So the correct answer is D. So this is a limiting reactant in enthalpy. So Na2O2 is the limiting reactant, because if you look up at the chemical reaction, you need 2 moles of Na2O2 for every 1 mole of sulfur. So if you have the same amount, then Na2O2 is going to be the limiting reactant. So you can make conversion factors out of these coefficients and this negative 610 kilojoules per mole. So negative 610 kilojoules per mole per 2 moles of Na2O2, or you can say negative 610 kilojoules of energy is released for every 1 mole of sulfur. So those are the 2 conversion factors that I can make from the enthalpy and the coefficients from the balanced chemical equation. So it doesn't matter which one you use. You just have to remember, if you did a little ice chart, that we're going to use all of the 0.1 moles of Na2O2, but you're only going to use half of the amount of sulfur. So either way, you're going to get 30 kilojoules. So sodium peroxide goes to sodium hydroxide. So in sodium peroxide, sodium has a +1 and oxygen has a -1. And then in the other side, oxygen has a -2. Correct answer C. If we look up at the values for enthalpy and entropy, remember, increasing entropy is favorable. So a negative entropy is not favorable. So you can assume that this is enthalpy driven because it is exothermic. Exothermic is favorable. Okay, so we're looking to match the graph up. Remember, in order to break bonds, we have to add energy, and we make new bonds, we release energy. So the energy we're adding to the system is 670 kilojoules. The amount of energy that we'll get back out of the system is 860 kilojoules. So the reactants have, we add less energy than we get back at the end, so we know it is exothermics, and the difference is 190. So you're looking for something that says we lost 190 kilojoules of energy, and the correct answer is A. Okay, so this is successive ionization energy again. Notice the first and the second and the third come off easy, and then there's a huge jump to the fourth. So that means that it has 3 valence electrons, and the 4th electron is going to be in the core. So with 3 valence electrons, it will form in correct answer of C, because it has a charge of +3 with 3 valence electrons with oxygen's -2. All right, here's another equilibrium. You're going to have to do an ice chart for this one. So 0.1 mole species. Now you're starting off with the same amount of each reactant and product. How do you know? Well, I look at the K value, 3.4 times 10 to the -4th. That means the denominator, remember K is always products over reactants. The denominator's bigger, the numerator's smaller. So we know that the products are going to get negatives and the reactants are going to get positives. So you can see that 0.1 plus 2x must be the largest, because the products are going to be less than 0.1, and CH4 is actually 0.1 plus 1x and not 2x. Okay, this is a heating and cooling curve. they're telling you they're heating it. They took ice and they're heating it. So they obviously are adding energy to it. So that's an endothermic process. So delta H has got to be positive. We're adding energy to it and we're changing it from a solid to a liquid to a gas. Remember, solids have the least amount of entropy, gases have the most amount of entropy. So if we're adding heat, we're also increasing the entropy. The correct answer is B. Okay, the next set of questions refers to this reaction of methanol, which essentially goes to completion. That means that we essentially get all products. Plus 91 degrees, plus 91 kilojoules, that means it's an endothermic reaction, so we have to add heat. The temperature of the contents of the vessel must decrease then, because what's going to happen, it's endothermic, so the bonds of the compounds involved are going to absorb temperature. Therefore, the container will decrease energy as the energy is being absorbed into the bonds. I did a little ice chart here for you, so you can see this. This is an interesting question. A sample of methanol is placed in a previously evacuated vessel with a pressure of P1 at 600. What's the final pressure after the reaction is complete? Well, it says it goes essentially to completion. So we're going to basically say that we have no methanol left. So when I started, I had a pressure of P1 of the reactants and 0 for the products. All of that P1 is going to be gone. So my equation becomes P1 minus X equals 0. And at equilibrium, I will have XCO and 2X H2. I'm going to replace the variable X with P1, and it becomes P1 plus 2P1 equals 3P1. So the correct answer is D. What can be inferred about delta S? Well, it has to be positive because one of the terms has to be positive. So if delta H is positive, then delta S has to be positive because that negative in front of that term in order to make delta G negative. Remember, a reaction is spontaneous if delta G is negative. A reaction is not spontaneous if delta G is positive. Reactants and products. Well, it's endothermic, so the reactants have to have greater energy than the products. So that's why it's endothermic. The correct answer is A. Remember acids. This is an acid-base problem. Remember that the pH is the power of hydrogen. So the lowest pH on there is obviously, and look, it's the lowest concentration too. So that means it's dissociating the most to cause the lowest pH. So that's obviously the strongest acid. Then we'll go to the other two. They have the same pH, but the lower concentration has the same pH as the higher concentration. Therefore, the correct answer must be D. 49 is periodic trends. They're in the same family, so you expect them to behave by like the element above them. So the correct answer is D. 50, you can do like PV equals nRT. This is a gas law problem. Or you can recognize that it's at 273 in 1 atmosphere, which is STP. So you can say that a gas has 22.4 liters for 1 mole. We don't have 1 mole, we have 0.56. 0.56 divided by 56 is 0.01. So that's why the correct answer is D.